Dear students, our today's topic is indefinite integration part 5. In this part, we are going to learn about partial integration method. First of all, we define rational algebraic function. If fx and gx both are the polynomials of variable x, the fraction fx upon gx is known rational algebraic function or fraction. There are two types of rational fractions. First is proper rational fraction. In this form, the degree of numerator is less than the degree of denominator. The second type is improper rational fraction. In this form, the degree of numerator is greater than or equal to degree of denominator. Some important forms of partial integration method. In left side we write rational form and on the right side we write partial form. First form is x upon x minus a into x minus b into x minus c. We can write it as a upon x minus a plus b upon x minus b plus c upon x minus c. Second form, in this form we can write x upon x minus a raised to power 2 into x minus b is equals to a upon x minus a plus b upon x minus a raised to power 2 plus c upon x minus b. In third form, x upon x minus a into px square plus qx plus r is equals to a upon x minus a plus bx plus c upon px square plus qx plus r. Fourth form, px plus q upon x minus a into x minus b is equals to a upon x minus a plus b upon x minus b. If given fraction is improper fraction, then first of all we divide numerator by denominator and rearrange it as improper function is equals to quotient plus remainder upon denominator. Then we use above concept to integrate it. Now we take some examples. Example 1, integration of 1 upon x into x raised to power n plus 1. First of all, we take x raised to power n is equals to t. Then we find its derivative, which is 1 upon x dx is equals to 1 upon nt dt. Now using partial integration method, we can write 1 upon t into t plus 1 is equals to a upon t plus b upon t plus 1. After simplification, we can write it a into t plus 1 plus bt upon t into t plus 1. Comparing numerators in both sides, we get 1 is equals to a into t plus 1 plus bt. This is equation second. Now we put t is equals to 0 in equation second, then we get a is equals to 1. Again we put t is equals to minus 1 in equation second, then we get b is equals to minus 1. Replacing these values of a and b in equation first and integrating it, then we get I is equals to 1 upon n integration of 1 upon t into t plus 1 is equals to 1 by n into, this is common, 1 by n is common. Now we can write 1 by n into integration of 1 upon t minus integration of 1 upon t plus 1. Then we integrate them and we get 1 upon n into within bracket log t minus log t plus 1 bracket close plus c. We can rearrange using property of log formula. We can write 1 by n log of t upon t plus 1 plus c. Now we can replace value of t, which is x raised to power n. We get 1 upon n log of x raised to power n upon x raised to power n plus 1 plus c. This is our final answer. Example second. Integration of x raised to power 3 upon x minus 1 into x square plus 1. First of all, we compare degree of both numerator and denominator. Then we get here degree of numerator is equal to degree of denominator. So it is an improper fraction. So first of all, we divide numerator by denominator. Then we get quotient 1 and remainder x square minus x plus 1. We replace these values in given function. Now we can write I is equals to integration of within bracket 1 plus x square minus x plus 1 upon x minus 1 into x square plus 1 bracket close. So here we can integrate 1 is equals to x. So we can write I is equals to x plus I1. Here I1 is equals to integration of x square minus x plus 1 upon x minus 1 into x square plus 1. This is partial form. So we rearrange it as x square minus x plus 1 upon x minus 1 into x square plus 1 is equals to a upon x minus 1 plus bx plus c upon x square plus 1. After taking LCM and simplify them, we can write it as x square minus x plus 1 is equals to a into x square plus 1 plus bx plus c within bracket into x minus 1. Comparing coefficients of x square, comma, x and constant in both sides, we get 1 is equals to a plus b and minus 1 is equals to minus b plus c and 1 is equals to a minus c. First of all, we simplify last two equations. Then we get 0 is equals to a minus b. So we can also write it a is equals to b. Now we simplify this equation with first equation, which is 1 is equals to a plus b. After simplify both equations, we get 2a is equals to 1. So the value of a is 1 by 2. Similarly, the value of b is also 1 by 2 because a and b both are equal. When we replace value of a in last equation, 1 is equals to a minus c, then we get c is equals to minus half. After replacing these all values of a, b and c in second equation, we get I1 is equals to 1 by 2 integration of x minus 1 plus 1 by 2 integration of x upon x square plus 1 minus 1 by 2 integration of x square plus 1 dx. First of all, we integrate middle part. Now we let x square plus 1 is equal to t. Then we can write 2x dx is equal to dt. When we replace these values in middle part, we get I1 is equals to 1 by 2 integration of 1 upon x minus 1 plus 1 by 4 integration of 1 upon t minus 1 by 2 integration of 1 upon 1 plus x square. After integrating all these, we get I1 is equals to 1 by 2 log of x minus 1 plus 1 by 4 log of t minus 1 by 2 tan inverse x plus c. After replacing value of t in middle part, we can rewrite it I1 is equals to 1 by 2 log of x minus 1 plus 1 by 4 log of x square plus 1 minus 1 by 2 tan inverse x plus c. So our final answer is I is equals to x plus 1 by 2 log of x minus 1 plus 1 by 4 log of x square plus 1 minus 1 by 2 tan inverse x plus c. Dear students, there are two special results for partial integration method. Result first is integration of 1 upon x square minus a square is always written as 1 by 2a log of x minus a upon x plus a plus c. Second form is integration of 1 upon a square minus x square. It is written as 1 by 2a log of a plus x upon a minus x plus c. Now we take two appropriate examples to understand it. Example first, integration of 1 upon x square minus 16. First of all, we write 16 as 4 raised to power 2. Then apply first formula. Then we get 1 upon 2 into 4 log of x minus 4 upon x plus 4 plus c. And at the end, we can rewrite it 1 upon 8 log of x minus 4 upon x plus 4 plus c. Example second, integration of 1 upon 9 minus 4x square. First of all, we rewrite it as 1 upon 3 raised to power 2 minus 2x raised to power 2. Now we take 2x is equals to t, then we can rewrite 2 dx is equals to dt. When we put these values in given question, we get 1 by 2 integration of 1 upon 3 raised to power 2 minus t raised to power 2. After applying second formula, we get 1 upon 2 into 6 log of 3 plus 2x upon 3 minus 2x plus c. The final answer is 1 by 12 log of 3 plus 2x upon 3 minus 2x plus c. Dear students, today's worksheet is attached with their solutions. Do it yourself. Thank you.